Yeah, we're live. Update tonight on the Pontiac 4-cylinder trophy motor. I got it to rev. That's right. I stayed late last night and put on some valve springs. I did a valve spring upgrade because we all knew, even people that didn't vote for it in the poll last night, I think secretly they knew. There were a bunch of people that wanted to jump ship and be with all the cool guys over there that were resisting it, but it definitely did need valve springs. And once I and I have an update on lots of stuff that I was wrong about last night. so stay tuned. I'm going to bring this in a little bit. First of all, somebody sent me all the specs on the camshaft and on the valve springs and stuff, and I measured the valve springs, and they were kind of spot on. The valve spring actually only had like 85 pounds of seat pressure, and it had like 160 open or so. So it was way off from where it needed to be. And so it was floating the valves. So I had a set of comp springs, some 901s. You can look up the specs on those. But those were 150 or 150 or more pounds on the seat and like 260 open. So they had more than enough. In fact, I was a little worried on the seat pressure. I was a little worried about the camshaft and the lifters. But it was the only thing I had, so it was going to happen. I just put those in. And it worked really well. So I was wrong about the seat pressure on it. I reevaluated that and retested it just to make sure. And so that cured. So now I can rev the thing all the way out to, I think I went to, we'll take a walk in there, but I think I went to 4,600 or something. But it's not making any more power. The power is the same. So while I had everything apart, I was looking for ways to change the rockers. Unfortunately, since it's a bolt down rocker and not an adjustable rocker, all of the stuff that I wanted to try that I had available to me, we didn't have any like long slot rockers or any Pontiac, stamped steel ones like 165s or whatever. All of that would have been nice. We didn't have any of that. So but while I was there doing the rockers, I thought, I'm going to check and see if this cam's worn out, and without having to take off the valley tray, I'm going to, spin them over and just measure the movement of the push rod. And I did. And I was amazed how little movement there was. There was between 210 and 220 thousandths cam lift. So you're talking about a cam that's like, and somebody supplied the specs, 330 is what it calculated out to. And actually on this, the intake and the exhaust measured differently. And the thing that I was interested in, as much as finding out how much lift this camshaft had and how mild it was, I was interested in making sure that all of the lobes were the same and they were all consistent, which they were. So it tells me that the camshaft is not, one of the lobes was not going flat. So that wasn't what was responsible for what I think still is a fairly low amount of power. If these things rated at 110, we should be making that or a little bit more than that. I know that this thing is worn out and it's got taper and wavy wall and, thrust load. It's probably oval. It's got all kinds of things that are bad about it. The other thing is, last night people were talking about having blow by, and I had indicated that I don't see any blow by. We don't see, because we've seen huffers. We've seen ones that are burning oil and that have lots of blow by, and they're puffing, and you could see that. But when I had it running, I actually took the caps off and felt the opening for the draft tube because it had a rag over it because I didn't want any splash oiling coming out. That didn't turn out to be a problem, but you can feel air movement, and I don't know if that's 4-cylinder related or it's a lot of blow by related. But either way, it's probably not good. So I checked that, and we fixed that. I did try one of the suggestions and I wanted you guys to know that this isn't a one-sided thing. I'm listening and reading all the comments and trying to answer them, but I'm taking all the information in and taking the suggestions. If there are things that I haven't tried yet, I'm going to try them. So because people were talking about, there's not enough timing, my heads need 40, 50 degrees, whatever people were talking about. We tried more timing and it didn't make any more power. It doesn't respond to timing. In fact, we went up to 36, 35 degrees, but there's just no change going from 30. In fact, when I went less than 30, and it seems to be one at 30 or 31, and going up did nothing, and going less takes power away. So that didn't work. One of the things I wanted to try that I didn't try last night is I actually wanted to try backing the rockers off, maybe with polyox. Pontiac guys have said that these lifters pump up and it's hanging the valve open, and I'd like to see if that was happening. Today, right before I got on, one of the things I was reading that made me think that something might be amiss. There's two things that I'm thinking about. One is I measured the movement of the crankshaft relative to the movement of the distributor, and it's a lot. So there's lots of slop in probably two things. One is the timing chain. I'm sure that thing is tired and worn out, because a lot of this stuff I'm thinking is the factory stuff. That's a standard bore piston. So, and I think the valves and the piston and the cam, I think all that stuff is the original stuff. So it might be that the timing chain is the original one. So it wouldn't surprise me if that's stretched. Somebody sent me a picture of it and said that these had a really good timing chain, and it's not the fiber timing chain that they used in some of the other Pontiacs that were problematic. This is actually a fairly good one, and it has a tensioner on it, which surprised me because I haven't seen that on a lot of V8s or half V8s. But still, I think that that's stretching. But measuring it the way that I did, it also would take into account slop in the camshaft to distributor engagement, so in the gear also. So movement in the distributor and slop in the cam and then slop in the timing chain, all of that. But it's quite a bit. It was 5 or 6 teeth on the flywheel, to give you an idea. And I'll show you, I marked it on the damper. So you can see the 2 slots. You can see how much movement that is. I didn't put a degree wheel on it to see how much it was. So that's one of the things. I'm pretty sure it needs a new timing chain. I mean, it's really old and it would need it. The thing that would be stopping it from making lots of power is having only 330 lifts. And somebody sent me, I wish I could remember his name. They sent me the information. He's here on the live feed. He normally is. So whoever sent me the specs on the camshaft specs, they were saying that it was 250 degrees of advertised duration. So it's tiny. I mean, otherwise it wouldn't be making peak power at below 4,000 RPM, and it's rated at peak torque at 2,000 RPM. It's 8.6 to 1. It's got a nothing camshaft in it. It's got a 1-barrel intake manifold. So it's just not going to make a lot of power. And I know that, but it should be making more than it is. One of the other comments I got from another guy was, and this is something that concerns me, is they said, make sure that the water pump is correct, that it has another backing plate on the water pump, which I don't think that this does. And so what I think is we might not be circulating water. And so I wish that I would have read that before while the motor was still able to make more pulls on the dyno, because I can't do that anymore. What I would have done, and we were talking about this when I originally put this on, if I couldn't find the right water pump for it, I'm just force feeding water through it. So that, because the motor, if you circulate, even if it doesn't have good circulation, if it has any water in there at all, when you first load it, it will usually be okay, but then it'll start to get hot. You can boil the water in the head, and it's just not a good situation. So that might be something. I'm pretty sure that. So there are 3 things that I'm concerned about. The water, one, because this whole time I've been dyno testing, it seemed to me that the cylinder head was hotter than it should be. We're obviously monitoring temperature of water coming out, but the way that we're monitoring it, we might not be getting an accurate reading. I'd like to have a reading of the water like right at the head, and if we're not getting circulation, we might be just bypassing most of it and not doing what we're supposed to be doing. So that's a consideration. The other thing is, in terms of power, that might be a thing, and that might be why it's not responding to timing also. Maybe we're rattling it to death, although I haven't seen anything on the plugs. And we've been, taking them out and checking them. But that, and then the blow by, obviously, this thing still has 20% leak down on it, so it's not sealed up. It's sealed up better than it was, so that it runs and actually makes power, just not what it could be. And then the timing chain. So the combination of those things, I think, would put us where this thing needs to be, which I know that we're talking about all the problems with the motor. Quite honestly, I'm amazed, especially if this stuff, and I think that it is, if this stuff is the original stuff that came with this motor in 1961. We're in 2023. You can do the math on how long that is. That motor is really, really old, older than most of us, and it's still wanting to live and run. a couple things that it's not the distributor, it's not the points. Like I said, we measured the condenser. The condenser's working fine. We put a dwell meter on it. We did a cylinder balance on it. Obviously, I measured the camshaft. I also did a cranking compression on this thing, and it's like 150. It's pretty even all the way across the board. I was very, very impressed by that fact. I mean, it varied 149 to 151 or 152 or whatever, depending, you know, you can vary it a little bit by how many times you crank it. But I was just happy that it was up somewhere near the same number. I expected them to be really low, maybe, and just wildly dissimilar, but it wasn't that at all. It was actually fairly nice. Given, you know, and I put a lot of effort into these Super Ritchie razor blade rebuilds, but honestly, the ones that were doing this to, like this thing, was just terrible. It wouldn't run. So it's not like, because I get a lot of comments about, oh, you're doing that wrong. You need to not use WD-40 because that's a water displacement. We know that. But you need to not use that. You need to have a different crosshatch. You need to use a flat. So yes, we need to do it right. But I wasn't looking at doing that. What I was looking at doing is I had that, and I had WD-40, and I had a drill, and I had a motor that was not going to run. And so if I combine all those things together, we made it run. Same thing. I got comments on the valve job. Oh, you can't do it like that. That's terrible. The drill, you can't do it. Yes, you can. You can do all of that. I mean, if you look at what other people are doing out there in YouTube land, and again, I'm not telling people that that's right. I'm telling you that if you have a broken motor, that will fix it. It will make it run. One of the other comments I noticed was people were concerned that I didn't measure the ring gap on the new rings that I put in. I did. It just wasn't in the video. They were about 35 or 36 thousandths. And I didn't gap them at all. That's just what they came out to be because they were brand new out of the box, and they were supposed to be 60 over rings, and this was bigger than that. Obviously, it was worn a good bit more than that. And so, again, the 36 thousandths ring gap is better than 127. So, again, it's not perfect, but it's much better than it was. And so when you're in a situation like with the cylinder heads, using the drill and lapping compound, if you don't have a way to cut them and do a proper multi-angle valve job, with probably sunken seats in this thing anyway, again, because that's probably the original head and probably the original valve job and probably the original valves. So you're only going to make it better. It's going to seal better than it was because now at least we have a circumferential like contact patch. We didn't have that before. It was pitted, you know, it was burned on a couple of sides, so it just wasn't good. So doing this isn't going to hurt it. No, it's not ideal, but we're looking at it's not working, and this is the right way to do it. The razor blade rebuild is kind of somewhere in the middle. The guys that argue are saying that it's way over here, but the reality is it's actually much closer to that side. So it worked and it ran, and like I said, I'm like wildly optimistic about how well it turned out, especially now that I could rev it. I mean, we'll go in and I'll show you the dyno results so you can see the runs from that I was showing you last night about it falling on its face to now it revs out. It's not making any, it's still making 95 horsepower or whatever, 165 or 170 foot-pounds, but at least it's charging all the way out to 4,600 RPM or, you know, whatever the maximum RPM that I ran at. It's all on the downside of the curve anyway. So after doing and we tried plug wires and timing. Oh, the other thing I did, I forgot. There's so many things. I put a long tube header on it, you know, because stock exhaust manifold is definitely holding back that 95 horsepower motor. Nope, not so much. Put a long tube header on it, you know, a little bit here and there, but not, it didn't go from 95 to 130 or from 95 to 100. I was at least expecting to see, you know, 3-digit power levels, but it was not to be. So obviously the stock exhaust manifold and then the little 90-degree elbow of, I think might be 2 inch. I have to measure it. It's 2 or 2 1/4. It's pretty small. Probably 2 1/4. I don't know. It's got a crush bend on it. It might be 2 1/2. I'll have to measure it and see. At any rate, it's more than big enough for what we're doing. And we didn't get any good scavenging effect. It seems like most of the gains were actually in the low and middle part of the curve, if you can call 4,000 RPM the high RPM. So we have a very, very mild camshaft. If everything was working right, if we had, you know, a concentric bore that was sealing, we had ring gap that was a reasonable amount. You know, given this bore size, I might run mid to high 20s in this thing anyway, if I'm going to run boost, and I'm going to run boost, but we'll run that after we redo this. So if we had that, and we had a good valve job done on the head, which is a good idea, and all that was sealing and all that was right, this combination is still limited by the three major things. Well, really only two. It has enough head flow to support way more power than this. We know that head, it has to flow 190 or 200 CFM. That tells us that right away we can make 200 horsepower with it because it flows enough to do that. We know on a V8 it'll make twice that. It'll support twice that. And on a 4-cylinder, it just supports whatever the airflow is. It will do more than that. In some cases, like this one, it will do less than that, and that's what happens. But so we got enough cylinder head. What we don't have enough of is we have a very, very small camshaft. We also have very, very low compression. I guess there are three things because we also have an intake manifold that has a 1-barrel opening on it. Now, those of the guys that have watched the channel before know that I ran a 1-barrel carburetor on the 6-cylinder 292, and then adapted that to the 2-barrel like I did on this one. In fact, you use the same adapter, it bolts on, it's the same pattern. So that means I can run my 292 1-barrel on this if we want to. And then I adapted the 2-barrel, and then I adapted a 4-barrel, and then I adapted a Dominator onto that. So I had a stack of adapters, and it still ran with the Dominator. It didn't like it very well. It actually made less power with the Dominator. But the interesting thing is it made a little bit more power with the 4-barrel than it did with the 2-barrel or the 1-barrel. So even though we had this tiny, tiny, tiny little opening, it needs a different manifold. So here's the other thing that I was doing late last night is I took the Trophy 4-cylinder intake manifold off and was taking a look using gaskets and other intake manifolds. I had the Edelbrock aluminum intake manifold out to find out if there was a way to adapt the later manifold to the early head, because that's the problem. I mean, it's not a problem. It's the 61 head. So if I was going to put a V8 manifold on there, which I can, and then cap the end, all of that will work. Cap the water, cap the 4 ports, run whatever manifold I want. If I'm going to do that on this cylinder head, I have to do it with an early intake, which means I have to buy a bunch of early intakes that I'm never going to use. It would be kind of cool to have a Tri-Power 389 intake manifold and that I could run, but it would just be a gee whiz thing. It's not going to be ideal for this combination. And ultimately what I'm going to do with this is I had somebody offer up machine work on this. So what I'm going to do is bore this thing out so that the bore is straight and concentric and sealing, and that the machine work is obviously done right. I'm going to bore this to a 400 bore. I'm going to, so that it's all working right, I'm going to have a camshaft made for it. In fact, I'm probably going to have 2 camshafts made for it. I'd like to do one camshaft that's like a Ram Air 2 or 3 kind of for this thing, which should be a huge step up from what's here right now. And then I want to put a late model head on it. So when I do the piston for it, I'll do a flat top piston. So we'll raise the compression. I'll do a flat top piston with valve release for a later head, put a later head on it so I can run all the later intake manifolds, which I have a few. I have the 2-barrel factory cast iron intake manifold, which a 2-barrel is going to be really good for this combination, especially if I run, because I kind of want to run this stock cam with this new configuration. So the 2-barrel intake would actually be an interesting choice for that. And then I could run, I have the Edelbrock Performer, which I can run. I have another dual plane high-rise style from Speedmaster. I have a single plane from Speedmaster, and the single plane also has provisions for EFI. What I probably will do with that intake manifold is cut all the other side off and make it into a dedicated 4-cylinder manifold. I won't be able to, with the late model head, I won't be able to run the 1-barrel intake manifold unless I cut it up. If I cut it up, I can do that. If I cut it up and use the, I could seal the other side, which it would work. I could use the crossover from the aluminum Speedmaster intake And it's cheap enough that I could just cut that and use that as a dedicated one, just weld up the other side. All of that could work. So I could run the 1-barrel intake manifold on. Ideally, I'd like to run the factory 4-barrel intake manifold on there. But at this point, I'm not that worried about it. What I could do also, before I could do a head swap. So I could also have this head done, run this head with the bigger bore and flat top piston, run this head, run the stock camshaft, run the stock intake manifold, run it again like that, and then take that stuff off and put the later head on, because we know that this camshaft, even with the flat top piston and the valve relief for the later head, this camshaft's not going to get anywhere near the piston. It just doesn't have enough. It doesn't have enough duration to even have to worry about that. It's barely coming off the seat. I mean, you know, come on, 300,000 lift and probably, I don't know what 200, and see, I don't know what that number is. I'm thinking this thing probably has like 180 degrees of duration at 50, the way that we normally associate camshafts. So it's just, you know, it's ridiculously tiny. So that's what I want to do. And then when I do that and run all those and run a slightly bigger, and then I could go do the cam upgrade, do a slightly bigger camshaft upgrade. I'd like to do a camshaft that's a flat tappet cam to stay flat tappet and run that, and then upgrade to a hydraulic roller setup. And then when I do a hydraulic roller setup, then we can get a little bit more crazy on it. And then, you know, while all that's happening, we'll also run a blower, the Torque Storm blower, and a turbo on it. And then, you know, then we'll be good. The other thing Speedmaster is supplying is a set of their CNC ported heads. So we'll have one of those that we can run on there as well. The only thing I don't know is I'm going to have to go through the heads and figure out which chamber size that I want to use. I'd like to use as small a chamber as we can. With a flat top, that's going to be less of an issue, but because this has a big dish in it. But I'd like the compression to be like 10-to-1 instead of 8.5-to-1. It'd be much better. Angle mill the stock head, please. It's a lot of work for 150 horsepower. My guess is with a late model, a later head, a later big valve head, and a flat top piston, and a reasonable camshaft and like the 4-barrel intake, this thing should be a lot closer to 200 horsepower. So let's see what you guys got going on. Let's take a walk in there and I'll show you the dyno results. So you guys get to see me rev it out, as it were. So I got all these heads to choose from. Whoa. But you can see the water ports are different on those. So we'll take a quick stroll in. It's going to get dark and scary ride here. Look, I don't know if you can see that. Maybe you can see it over here. There we go. Come on. Give me some light. Give me some light. Yeah, I don't have any light. It's a, I think it's a Tri-Power 440. It's a 6-pack. Okay, so this is the motor, the 2-barrel adapter there. That's full race. You can see, obviously, full race. I've already taken the header off. Whoa! In fact, why don't you guys hang out here with me, and I'm going to take this water pump off, and I'm going to show it so somebody online can tell me if maybe this was actually a problem. Maybe we can look at that. My Mazir electric water pump. So this is the water pump head on here. There is no, I'm sure somebody's going to ask, there is no thermostat in there. my gasket now. Okay, so whoever my water pump guy is, that is the water pump. Well, and maybe it might be that this is the vacuum plate that they were talking about, so we might be okay. I don't know. So I'm gonna untangle you. So this is what the inside looks like. So is that correct? Did I step correct? See, I don't know if this is worn away or if that's the way that it's supposed to be. Somebody please let me know. No thermostat in there. Water goes into the block, through the head, back out here. This passage back here is closed, it's blocked off by the intake manifold. But this thing always just seemed like it was hot to me. Okay. That thing's ready for me to yank it off. So let's take a look at our fancy Dyno results here. Get you guys all set up. Okay. Data. I like that. Trophy 4-cylinder. So, can you guys see that? Let me turn that around. How's that? Better? So that's the stock exhaust manifold versus long tube header. Big power. So the black line is the header up above, and this is torque, this is horsepower. That's the header, and then that's the stock exhaust manifold. As you can see, revving all the way out to 4,300 RPM, and I did run one that was higher than that, I think. Let's see. Yeah, with the header. Yeah, look at that. All the way out to 3,600. But it's nice and flat. And in case you're wondering, this is what it used to look like. See this right here? Yeah, that's the springs not being happy. Wah, wah. So we got lots of RPM now. I'm going to pressures, fluid and air temp, yeah. Okay. The other thing I did, and I had to do this visually because for some reason the manifold pressure wasn't working on the dyno. I think that they've got a bad sensor or something there. I just was kind of watching the vacuum gauge, and this thing at idle has, it has like 20 inches of vacuum because we have a vacuum / boost gauge. So it's got about 20 inches of idle vacuum. And I was watching it wide open throttle. It might have an inch or an inch and a half of vacuum at wide open throttle at the top. It's not as bad, like it's typical. The vacuum increases with engine speed. Although the thing is, this isn't showing a big increase in power as we go up in RPM. It's going from 85 to 95 horsepower, but it's going up in RPM. Frosty cold beverage. Okay, so let's see what you guys got to say about the Trophy 4-cylinder now. Yep, Dan, it won't rev high enough to get to the crossover point. That's when you know. Make it unequal length header. This already has an unequal length header. The Pontiac one is unequal length. The timing chain needs to come off. It needs to be checked, definitely. Pneumatic wrenchers in the house. Yeah, this thing is literally begging for well, it's begging for a few things. It's begging for seal. It's begging for a timing chain that's not sloppy. It's begging for an intake manifold. It's big, but it definitely needs a camshaft. I mean, this camshaft is really tiny. There can only be a big change in power from the camshaft. Sheet metal intake. Well, I have that single plane if we wanted to do that, but right now it's not in a position to take advantage of much in the way of intake manifold. A dual plane 2-barrel intake manifold would be about all that this thing can handle right now until it gets more camshaft. Increase the area under the curve. Yep. 2 or 3 foot-pounds under the curve is a lot when you're talking. It's 2 or 3%. That's the same springs that come in the Bic ink pen. It is. It really is. The comp springs are actually pretty good. I was looking at trying to put. I found some like L98 springs, and I was just going through all these used takeoff, factory kind of flat tappet springs, but just none of them worked out except for these. Time for a GT45. I want this thing to be in the 150 to 200 range before we put boost to it, because it needs to be making a reasonable amount of NA power. I mean, this thing isn't even making 1 horsepower per cubic inch, and there's enough cylinder head to easily do that. We have a detonation problem having a small cam with high compression. No, because we'll have enough octane and we're running it cool enough, assuming that the water pump is working. I'm currently running an overhead cam 6 with a draw-through setup. That's cool. I kind of want to try a draw-through setup. I've been wanting to try that on something, and this would be a good opportunity because that's kind of an old school deal. Plus, it gets, a draw-through gets intercooling. And I'm definitely going to do a draw-through because I'm going to do a crown version, the old crown version. For if any of you guys are 240 or 260Z guys, the crown turbo used a single Hitachi carburetor or an SU in front of a turbo blowing into the factory 6-cylinder intake, the carbureted intake manifold. So I want to do that, and I won't care about the turbo not having a carbon seal in it. The advance is fine on the distributor. We can see that when free revving it. Racer, you're right. The intake manifold is a low rise. It's kind of like some of the Corvette stuff that you've seen, or Cadillacs are like that too, where the air and fuel has to go down and then up into the ports. You can see that on the intake manifold. It's not optimum. But right now, that's not limiting it, I think, nearly as much as the opening in it and the fact that it doesn't have a lot of draw. Because if I saw 4 or 5 inches of vacuum, I'd go, oh yeah, the intake manifold is or the carburetor is way too small. But that's just not the case right now. Yeah, Holly has a 1-barrel and 2-barrel carb EFI. That would be good. What I'd like to do is put one in the middle and then 2, one on either outside where the runners are, and then have a tri-power, which would kind of be cool. I'm pretty sure that that timing cover doesn't have the divider plates. I don't know what the difference between them looks like. I'm gonna have, now that I saw that comment, it happened right before I got on for the live feed. So I'm gonna go do some research on that. Poll should be Atlas 4200 versus 4300 versus Buick 3800. I would pick the 4200 on that. The 4200 makes the power NA that the 3800 does with a supercharger. Put a fresh valve tray and cam. Yep. Offset grind the crank. Not going to do that. The crank is going to stay the way it is. It's just going to get polished. Side draft Webers would be good, but I don't have those. I don't have any side draft Webers. Check out. So Problem Child Projects is here promoting Problem Child Projects. Maybe do a test with a blow-through carb and then with an intercooler, see the performance difference for horsepower. I've done tests on I did that on a big block where we ran a blow-through carbureted deal and then ran a blow-through carbureted deal with the intercooler. And the intercooler always helps. It's always good, even on a blow-through carbureted application. Turbocharge a CT90. I have that, and I would like to do something to make it more powerful, just a little bit, just a little bit more power. No, overbuilt. Richard, go pull the timing cover off, skip a tooth on the chain, and run it real quick. We could determine from spinning it over whether or not it's a tooth off. If it's a tooth off, we would be able to see that in the alignment of the timing chain. Winston, nobody makes shelf cams that I know of for this. It's going to have to be a regrind or some sort of custom deal. Cam, this is probably the lowest horsepower version. This is the 110 horsepower version, but it should at least make that much. What are you going to bump the compression up to? 13? No, no, thanks. I don't want to do a dedicated NA build. I don't like those, because if you're going to go to 13, you should go to 15. If you're going to make an NA motor that's only an NA motor, obviously, and it's not going to be boosted, you don't go. Brule always hates that. Why go to that middle ground? Why make it a 12 or 13? If you're going to make it run race gas in it as an NA motor, then you need to go all of it. It needs to be 14 or 15. I'm going to go to like 10, because then with 10, it will make good power. It's right in the sweet spot of making power for compression, where you're not on the downside of that bell curve. From 8 to 12, I say is kind of the bell curve. 10 is right in the sweet spot of that. 10 allows it to make good power NA, and then 10 also allows me to run boost with the 85, and we can do whatever we want. It'll make 300 with boost. It'll make a lot more than that with boost. Guys are already making way more than that with this thing, with versions of this thing. Will a double roller timing chain fit under the cover? The stock one looks pretty thick from the photo that I saw, but I don't know. I don't know what the depth is. I've never taken this timing cover off. You want me to JB weld the domes on the pistons? All I have to do is fill in those. Yeah, you can put boost on a 15-to-1 motor if you want. So Racer, okay, that challenge accepted. The challenge is to make more power than my 186 Iron Duke, 220 foot-pounds at 172 horsepower. Yeah, I think that's not. I don't think that's a tall order given the displacement of this. I don't know what that Iron Duke head flows if you guys did a bunch of porting on it, but we have 300 CFM heads to choose from, so that shouldn't be that hard. Dan, if you have a cam made, you can try Oregon cam grinders. I was talking to those guys, or somebody was steering me in that direction on the Slant 6, I think. How many mains does it have? I don't have to look at the photos. I think 5. Check the balancer. I can check the balancer, except that the way that I do it eliminates the balancer as a possible incorrect timing thing, because we just start with low timing and then just start adding timing until it stops making power. So I honestly don't care what the trigger number is. All we care about is that we started low and we kept adding timing, and if it kept making power, we would keep adding timing until it's not making power anymore. So again, whether that number is 42 or 36 or 11 or whatever it is, that's where it stopped making power. And so people get wrapped up in that. They get wrapped up not just in having the number, the absolute number, and then we get the number afterwards. And again, it's the number with that timing light, because I've seen variations in timing lights. So if you consistently use that timing light and you're lining it up in the same spot on that motor, you just keep using that number. But people want to use that as absolutes, like at the track and other places with other timing lights. And that's not always adaptable. That's why on the dyno, the people don't like that you have to use a specific timing light and that dial back doesn't work and yada, yada, yada. And I'm like, look, this is the way we do it. We start out with 20 degrees, somewhere near there, and then start adding timing. And we're going to get to a point where it just doesn't care after that. And I don't care what that number is, but that's the maximum horsepower from timing. Racer, 195 at 400 lift. Yeah, that's not great. That's enough to make, you know, you could make that kind of power. Have you already opened it up? Yeah, Hugh, you need to look at the video that I have up. Not only did we open it up, I had to ball hone it, do a razor blade rebuild, all kinds of stuff on it. I'm still doing the Maribera. But Jeremy was never porting ahead for me. That was only for Calvin. Stick a K24 A2 head on it real quick. That would be good. I was also talking today to the Car Farm guys about the 2.2 liter Dodge Omni. I'm very excited about that. How come Freiburg and Dulcich never joined in the chats? There's nobody here. I'm the only one here right now. And the only time they've ever been on the chat was when I did a live feed after I helped them with one of the Engine Masters shows, but I'm not part of that show, and they're obviously not part of my live feed. They're always welcome here because they're cool guys, but you know, they're like movie stars and they're way too busy for that sort of shenanigans. Admiral Richard, if you're going to run an 87 octane with 10.5 to 1 4.6 all motor, what time would you start with? I don't know. I don't remember what is that, a 4-valve motor or a 2-valve motor? I can't remember. I'd have to go back and look at the notes and see where the timing was. I'm thinking that they were 30 degrees, so I would have less than that. And then it also would be a function of the cam timing and what you've done to the chambers. Richard, I think you missed a comment. It may be that stretch, and if you skip a timing tooth, that would add a bit of extra being just perfect and run it real quick. Yeah, so just go in and take the timing, take the front cover off and re-dyno the motor really quick. That's not going to happen. How about using this motor for Tempest build in a factory appearing stock tire class, a 9-second 4-cylinder Tempest? The fastest NA1 that I've seen is Lindsay's running 11s, I think, in his. Aaron, maybe you were the one that was telling me about the Oregon Cam place. Richard, awesome, serious question. 4302, 80-pound injectors. What size fuel pump should I use? The fuel pump, like the injector, should be chosen for what sort of power level you're doing. And obviously, in the fuel pump side, you also have to consider what pressure it's going to take. The best thing to do is oversize the injector a little bit so you don't have to run a lot of pressure from the pump, because less pressure supplied by the pump will increase the flow rate of the pump. But anywhere from 342 up to, I think that there's 450s and stuff now for in the tank pump. So I don't know where you're mounting it or what the combination is. Dan, did you happen to look at the cams? Yeah, were you here when I did the discussion earlier about that? I measured the lift on all of the cam lobes. They're all consistent. And they're all what they should be. A whopping 330 lift is what this camshaft is. That's 330 lift at the valve. it's only 220 at the cam. Admiral, 18 degrees should be safe on a PI2 valve. Hopefully you've massaged the chamber. Yeah, you guys should check out Dave Racer D's Super Duty. Oh, yours isn't a Super Duty, right? Well, Dave, help me out. What motor am I trying to think of that you guys just did? You guys, not just, but you need to look at his video on the. Somebody tell me what it is. Iron Duke. That's what it is. He did an Iron Duke build on it, so it's pretty cool. Oh, that's right, Cam. The title has forward piston to valve. That's the other thing I'm working on tonight. In fact, I was working on it before I came over here over at Sanchez's place. What we're doing is I have a production 5-liter, probably an 89 or a 90, I think, and with a stock head, never been off. It's all original stuff. And what we're doing is measuring piston to valve clearance. So we're measuring piston to valve clearance on a stock camshaft that's in there right now. And I have a couple of other cams that we're going to try. And then I may also try, I have a set of Airflow Research 185 enforcer heads. So we may put those heads on, take the stock head off, put those heads on, and then measure the change in piston to valve clearance with one of the camshafts with that other head, which I'm certain is a much bigger valve. Oh, so we've got to have a poll for tonight too, right? Because it's almost time to go, so we'll have a quick poll. Is the timing chain loose on the Trophy 4-cylinder? Ask your community. Yeah, that's good, Bell. Oversized injector and fuel pump by a lot. If you're going to run boost, you're going to want to run more boost, and then you're going to run E85, and all of that's good. All of it should be oversized. You can obviously take injector pulse width away, but once you're at 100%, you can't add more. I'd like to run an Iron Duke also. I think that would be cool. I just want to put one on the dyno and hear it rev up and make noise, and then have it make boost. Overbuilt. Richard, I mentioned Delta cams to you a time or two in the chat. They're located in Washington. Very good price on a wide range of services. Last time I dealt with them. Cool. I'll have to check them out. Yeah, 220 lift at the cam. Thank you, Bell. Thank you very much. Sorry for being late. Was working on the bread. Good. Hopefully it's making big power. Daniel Butler says the stock Pontiac blocks turbocharger are good for 900 horsepower. Does that mean this one's good for 450, or is it good also for 900? I see some limitations in this. I was talking to Andy from Hardcore, I think it's Hardcore Engines, or Hardcore Racing Engines. He's going to be here on Monday testing something, but I know that the guys make the supports for the lifter valley. The Pontiac 400 block that I have has provisions for a 4-bolt caps. It is a 2-bolt block, but it has provisions for a 4-bolt. So maybe, I don't know. I don't remember now. I think I have photos of it. This was a 2-bolt block, the 4-cylinder one was, and I don't know that there were provisions for the 4-bolts on this. Yeah, Admiral, if you're going to add timing until it knocks, you only want to add a little bit of timing at a time, and just be ginger with the throttle. Not Marianne, be Ginger. Would it hurt my 99 4.6 liter to put a turbo on it? No, as long as everything is right. If the tune is right and the charge temperature is right and you have it intercooled and all, and you have low boost and all, it'll work fine. Delta lobe welding, bearing areas repaired, hard weld buildup, rocker arms resurface, follower resurfacing, lifter regrind. Oh wow! Do they weld on the bottom of the lifter and then reflatten it, or do they just like surface the existing lifter? The cam is so little, I don't know how the chain could have stretched. Yeah, maybe they over-revved it. Maybe they over-revved it to 4,000 RPM. Put the motor at TDC, then rotate counterclockwise, watching the timing marks and see how many degrees go by until you see the rotor move. We were just talking about that earlier. I did that already. Oh, I forgot to show you guys that. So I can show you how much slop was in that. So I'm glad you mentioned that. But we did that test already. It was 5 or 6 teeth on the crankshaft, or on the flywheel, the starter teeth on the flywheel. But you should be able to see where this was. So I'll set you guys down. I have to pull my. Okay, let's see if we. Okay, here we go. See this mark and this mark? These two? That's how much this moves before the distributor moves. So it's that much. That's a lot. That's more than you'd want it to be, at any rate. So I'm hoping I get an answer on the water pump. That's kind of what I'm curious about. But see, what I was doing was in here, where the flywheel is, I had it marked, and then I would turn it and move it until I saw movement on the distributor, and then I could see how many teeth it moved. And then I decided to just go do that up front and mark the balancer. And the balancer actually has not slipped because I TDC'd this motor, Super Richie style with a screwdriver, but it's really, really close. I mean, if it slipped, it's not slipped hardly at all. So it's mostly at TDC. Let's see how our poll is doing. Guys, get up, hurry up and vote. Lots of people here. Rock the vote, hurry up. Because times are running out. Is the timing chain loose on the trophy 4-cylinder? I just showed you what was going on. How could you not go vote for that? So make sure that you go out and vote. I just showed you the answer. The 1964 Tri-Power 389 did 348 horsepower, so go for half of that 174 with a 2-barrel on a better intake. We would need a 4-barrel, which this motor came with. This motor was rated at 166 in 1963 with a 4-barrel, factory 4-barrel intake manifold. So I'm pretty sure it would do that. Crank trigger ignition. This thing has no problem really, I think, with ignition. It does like more dwell. We ran it from, down in the teens where it wants to misfire all the way up to 60 or 70. It ran fine there. Richard, Delta surface grinds the lifter with an old machine to the best of my knowledge, as long as it's not worn out. I just don't know how much thickness they have, and if they get past this. I'm sure those things are surface hardened, right? So I just don't know what the depth of that is. Yeah, a 340 liter per hour pump is probably not enough to max out 80-pound injectors. They have bigger pumps than that, though. The worst example I've seen of a loose timing chain actually was on my dad's Blazer. It was so sloppy that it wore through the timing chain. So it had so much slack that when it was going around, it kept hitting the, the tin kind of timing cover, the stamped steel one, and it wore a hole through it. So that's pretty bad. That should have jumped long before it did that. A stretch chain will retard the timing. And the thing is, which would be the worst possible scenario, in my opinion, for this motor, because it's only a 4,000 RPM motor. In fact, a sub 4,000 RPM motor. So if you retard the timing where we're going to make more power on the big end, it's already past where it wants to make extra power is already way past the power peak, I'm guessing. You should try to do a modern version of this engine using a Hellcat. Using a Hellcat what? A Hellcat blower? Is that what you're talking about? Camaro Rick, I think the Tin Man does have a sheet metal. I don't know if it's sheet metal or tin. Can you upgrade to a flow cooler water pump? What is that? It needs a dual mass flywheel. Does it seem to vibrate at power? And actually not. It actually sounds pretty cool. The 166 horsepower was more compression, and it had more camshaft, and it had a 4-barrel. I don't know about the cylinder head. I haven't found that information out to know if it has a different cylinder head than the one that I have on here. I've never seen a timing chain jump. I've seen timing gears break, but I've never seen one jump a tooth. The only time I think I've ever seen that is on a belt. Have you ever used an Optron or high-speed video to valve measure? I haven't. I'm not at that level. Oh, valve train motion. Okay, that makes more sense. I've seen those. Comp has some really good ones. Comp has some really cool ones where they show the spring oscillation and movement, and then they also show the, which is really cool. They show the opening the valve, and as they're let's see, they were opening the valve, and then when the valve was coming back up, the keepers were coming loose of the valve, and then the retainer would come back up and then and then push them back in place. It's really kind of scary. That's right. That's right, Arc. That he didn't already have. I do need new merch. I just need merch. It doesn't even have to be new. Yeah, Casey, too bad Holley doesn't make a split 2-piece intake for the Pontiac. If we can run these with go with the later head, we can put tunnel rams and stuff on there if we want to get silly with it. I could make my own, which I think would be cool. That stuff is used on Spintron testing. I have seen that. They make both 8 and 11 bolt water pumps depending on the year range. I don't know. Is that were you talking about some other kind of specialty water pump or something? Maybe you should have checked the valve train on the Spintron. Yeah, will a Spintron even go to 4,000 RPM? Pneumatic, you could help design stuff. What I'm looking for now is I want to do an intro graphic for all of my videos. And I want an intro logo that it's part of that graphic and use in other spots and in shirts. And then I could do the every cam is a turbo cam and all the and the different kinds of shirts. Did you run a timing curve? Yeah, it has the factory timing curve, but it's all in the range that we're running it at. I put softer springs in the distributor. Get Edelbrock to spring for one of those heads. The Edelbrock guys are really good and would give me a head. It's just that they don't have any. The Trophy 4-cylinder is a 2-up, 2-down crank. You can find the Flow Cooler brand. I don't think that this thing has a cooling problem that's related to the inability of the water pump, as long as the water pump is right. .454 High Pro, any good? I don't know what that is. Not so sure. I boosted a V8 and I got tons of torque, but not much horsepower. You should get both. What you get when you add boost is more of the existing power curve. Boost just multiplies the stock curve. Oh, pneumatic, yeah, definitely send me you can send it on Facebook, or I put my email up here all the time. Tunnel ram would be easy to bolt onto the downdraft Weber manifold, but on a couple of 44. Oh yeah, you could run, I don't know what the spacing is for, I'd have to measure that. What is I don't think we have any Webers here. I don't think we have any IR manifolds on anything that I see. I don't see anything. That'd be a good idea to measure what the port spacing is on a tunnel ram versus what the distance is on the Webers. If anybody knows that, take a look at that and let me know. Samuel, I have looked at the Mercruisers that have the big block Ford head on. Those are really cool. If you were me, what would you do on a 99 F-150 when it comes to power chip? I don't know about any of the chips on any of the factory style computers because I don't ever run any of that. Rust scale doesn't transfer heat. No, is rust in here. Richard, as a future other guys, grab a front-wheel drive Caddy V8 Northstar. I already have one of those, Dirty Peanut. I already have one of those. Mark Sanchez has one that he took out, and it's a running one. So that could go up on the dyno also. 1973 454 LS7s, are they any good? I didn't, an LS7 in 1973 would have been a GM crate motor. So it would have been a 12.5-to-1 solid cam. That would have been an aluminum headed motor, but an iron block. So yeah, they're good, but they're going to be cantankerous. Have you ever messed with an F23? I think that's a Honda. I haven't. I've done a lot of B and D and K stuff and some F stuff, but not an F, the S2000 motor. Dan, if you're going to keep doing the Ritchie rebuilds, I have a working valve grinder that I'll donate to you. That would be cool. You can do valve grinds and back cuts. That would be cool. Just do a, just a kiss, just a little clip. What is your opinion on the sloppy stage 3 cam versus the best cam versus the Chuck Norris cam on a stock 5.3 long block? My opinion is that the best cam and the Chuck Norris cam, that video is up and you can see exactly what both of those do. The best cam is a little bigger. It makes a little more power on top and less power down low than the Chuck Norris cam. The sloppy stage 3 won't fit in the stock piston to valve clearance application. So it's something that you could only run if you put notches in the pistons, if you had valve notches in it, or aftermarket pistons. What are you going to do with this 4-cylinder Pontiac? I'm going to keep running it on the dyno. It's not slated to go in anything, if that's what you're asking. Preston, I know I'm changing the subject. That doesn't matter. We're open for every question. Whether 302 is a sleeper or speed truck, can you email me, help me, so I can give you full details? If you have questions, this is a good place because I'm not the only guy that can answer stuff. If you tell me what you're doing, I'm sure that I have built a 302 or some kind of variant that will do what you need it to do. Because remember, boost is always the answer. What was the question? Former coworker has a Pontiac Trophy 4 in his yellow T-bucket, used a torquer intake manifold. We have a torquer intake manifold here with the driver's side plugged up like we were talking. That will work. The torquer is not going to be a good manifold, and we'll see that when we test it. It's not going to be a great choice for this. The dual plane is going to be much better for this kind of RPM, but waiting for a 6.8 V10. The guys at the car farm, the 2.2, 2.5 / SRT4, they have all kinds of stuff there, but they have a Triton V10 there. Austin, apparently the F23 head single cam flows better than an H22 and any B series motor. That must be a lot. I remember, is that the one, is that the F series motor that Beezy was doing a bunch of stuff with? I just don't know anything about it because I've never seen one. I mean, I've never seen one, taking it apart. Guru, is it best to get an LQ9 block or keep an L76? What's the best combination? There's no best combination. There's just every combination. With that motor, and you want to make 650 to 700 horsepower, you just have to run boost on a stock motor. On the L76 motor will work. Just put cam and springs in it and run boost on it, and you'll be right there. Why doesn't anybody make a good torque cam for the 3rd gen Hemi? The Hemi is, they do. The new VVT motor with the dual runner intake manifold is a good torque cam. How much piston and ring gap for a Forge 408 and a 250 shot? I don't know, a 250 shot would be, I'm trying to think what we ran on the 5.3, we never put ring gap in it. We ended up breaking it. So I would put more than that in there. Let's just say 25. Edelbrock does do Pontiac heads. They just don't have them in stock. Michael, sorry if I missed this from earlier, but what is keeping the RPM range so low? A lot of things. The intake manifold, it's a 1-barrel. The camshaft primarily, because it's really, really tiny. It's a 330 lift cam and no duration. Preston, it sounds like you need boost. KW, thank you very much. You need to rephrase your question, though. What's your opinion on EcoBoost stuff, 4-cylinder and V6? The EcoBoost stuff works good. I've never run one on the engine dyno, but all the stuff that has been run on the chassis dyno, that stuff works good. Preston, that's going to be one of the problems is your transmission and stuff. It's easy to make power, but getting the transmission to cooperate with that. And KW, just ask the question just in the regular comments. You don't have to apply money to it. Fascist, that's 330 at the valve. It's only 220 at the cam. Are you planning to up the RPM range as part of the build process? Oh yeah, it'll make power at a higher engine speed than this. It has to. How many engines have you seen blown up on the dyno? Not very many. We blew up a few. Chad and I blew up a few on purpose, and people got mad. Why would you go get a small block Chevy that's running and put it on the dyno and then purposely blow it up? Because that's the TV show that we were doing. We've seen a couple hurt themselves for a variety of reasons, but not that many, though. Are you just not interested in testing EcoBoost? The problem with any new motor is getting it hooked up and running on the dyno. It takes a long time to do that. And a lot of times I don't have a week to spend or more to go through and get a new thing up on the dyno and get it running and not be doing anything else. I'm not making any money, and you know, my family needs to eat. Michael, Speedmaster does make heads. I'm getting a set already. Did you ask your question again? Did the gentleman? Richard, do you lose any power NA with ring gap? We didn't on the 5.3. Did you take apart and clean the lifters on the trophy 4-cylinder? No, they never even came out. Good. Overbuilt. Good luck on that. I would walk soft. Richard, do you subscribe to the belief that different firing orders can make more power? I don't think so. We've tried 4.7 swap stuff. When they do a change, like when they made the LS firing order different from the small block Chevy, they're doing it for longevity and second and third order vibrations, and they're trying to change NVH, and it's not usually done for power. Bell, same reason you don't see stuff like the 3rd gen Hemis. I've run lots and lots of 3rd gen Hemis up there. I've run lots and lots of modular Fords up there and other unique engines on the dyno. I've run lots of those because those are, we have bell housings for those. We have management systems that work for those, but I don't have a management system that I know. We don't know what works on the EcoBoost because I don't know what the trigger patterns are. I don't know what the bell housing is. I mean, we can find out all that stuff, but I have lots of other stuff that already goes up there and runs. So I have to do that stuff. I have to get all of those motors together and run before I can just get more. The Slant 6 is still sitting there ready for me to put the head back on. What is the newest and oldest motor you have? Right now, the oldest one is that trophy 4-cylinder. No, I take that back. I have a 57 347 Pontiac that I haven't run because I don't have a bell housing for it because that takes a weird bell housing. That's the oldest one. And the newest one is probably the Gen 5 L83. Austin, you got a 66 Chevelle with an L86, 9-inch or 12 bolt. That's not going to be a function of power. Either one of those will work with the power that you're talking about. So just look at cost and look at, you know, ease of swap and stuff. I have more Barra testing coming, or some Barra tests coming. Jerry P, piston flip and firing order stuff is for harmonics and vibration. Piston flip is not for either one of those. That's firing order is actually a real thing. Piston flip doesn't do that. Does Liv's overhead cam 6-cylinder have spun bearings? I don't know about the bearings. We haven't checked those, but she did say that the I thought she said that the valve train stuff is the cam's flat. So we're probably gonna have to do a cam in it. Changing firing order, coupling alters the power delivery to the ground. Look up 500 GT Big Bang or droner motors. I know all about that. Not all about. I've researched a lot on the Big Bang motors and know what that does. Very, very specific application for power application on that particular thing as they're trying to exit a corner. So it was done for a very, very specific thing. People are not looking for that. People are not looking for, we had to do this thing to solve this particular problem with this kind of motor and rider and bike on these roads on this application. There, people want universal things. Oh, if I change the firing order, it makes more power. That's what they want, and it doesn't do that. Piston flipping cures small smoke puffs at startup. That's what I need on that one, huh? I need to flip the pistons. I need to flip them by selling them and putting good ones in there. Jerry, I don't know what you mean by revs faster, not necessarily more power, just sooner. How would it rev faster and not make more power? How would that not change? How are those two things not related? If you put a light flywheel on there, it revs quicker. But guess what? We see that as power. You can talk to me all you want about piston flipping, but I've tested it on the dyno and it didn't show anything. Now I want to do other tests with it on a chassis dyno or a change in rate of acceleration on the engine dyno, whatever. There's lots more testing to be done. But somebody telling me that it hits the converter harder or that it revs snappy or whatever, that's not an analytical approach, and I'm an analytical guy. What bell housing does a Trophy 4 take? It takes a BOP or a small block Chevy bell housing. The one thing that's different, though, is the bolts that are securing this, the transmission bolts, are bigger on the Pontiac than they are on a small block Chevy. So the bell housing holes are not big enough for the bolts that you need to hold the engine on. So what I did was put 3/8 bolts and ran them all the way through and put nuts on the other side, and we called it good. Do you think it's worth it to knife edge a twin scroll turbine being used on an open flange? Are you knife edging the front side? The thing that I'd be worried about on that, you might knife edge it. You might. It's going to make you feel better, so I would do it just for that. I don't think you'll see any power difference. What I don't like is heated exhaust going across those sharp edges and having a tendency to knock stuff off. I say that because I've had situations where we've run gaskets that were slightly smaller than the opening in the turbo or the flange, and the overhang, the hot exhaust gases, like knock that stuff off and put it into the turbo. It's not good. Does changing fuel injectors increase power or miles per gallon? No. And yes, you might be able to change the atomization or the spray pattern, but it would be really hard just from a change of injector to do that. You're not, and we tried it. I tried it on the Chevy Sprint because I wanted to change. I tested the spray pattern on the injectors that came out of the Sprint, and then I put injectors that had a different spray pattern with more atomization. I think the ones I put in were either from a Honda or from a Mustang, because we got a million of those laying around, and it didn't seem to change fuel mileage, because the biggest thing that you can do is the way that you drive. So you have to be real specific about your test driving procedure, and to be much better like in a laboratory to do that. It accelerates faster, but the total peak remains the same. Time the sweep through the RPM range. What you're talking about is a change in power through the curve. We would see that on a dyno. You can't change acceleration rate without changing the power. Having a terminator for engine management is easy. Having complete harnesses for 100 different platforms, that is hard. The harness is a difficult thing. I mean, we have universal harnesses that we could do with a lot of stuff, which is evident by the fact that we did a stand start on the 2.2 liter Dodge with an LS V8 harness. So you can make stuff work, especially when you have Ish and Eric here to make it work for you. BOP bell housing top bolts are different than the Chevrolet. They are, but this one doesn't use all of the bolts that the BOP does. And the bolts that I was interested in were the ones down by the dowels. Battle Track, the lift on the Trophy doesn't sound right. The V8 had 407. I don't know why they would change it for the 4-cylinder. Well, all of that is speculation on your part. This is the actual valve lift, and I checked it. I checked every one of them, every intake and every exhaust, and somebody looked up the actual specs in, he told me what the name of the manual was, and they have the actual lift, they have the actual duration, they actually had the valve events, they had everything. And the lift was exactly on with what I checked. It's only 330 lift. Yeah, Dan has tested piston flipping too. I know people want that to work. I told Uncle Tony when I was on his show, I said, I want it to work. I want it to be one of these old school, like magic things that actually produces something. And I want to see it make power. It just didn't. And I'm just reporting that it didn't. I'm not saying that that's an absolute thing, and maybe we tested on a chassis dyno, or like I said, a change in acceleration rate. But if it does anything, that thing is measurable. It's not just a feeling. It's not just a subjective thing. If there is a difference in acceleration, that is definitely measurable. It's measurable on some sort of dyno or device. There would be a way to do that. And until somebody shows me that does it, does a back-to-back test and shows me, it doesn't do anything. Have you ever tested different piston quench heights? Example, flat top piston in the hole with 0 deck piston with a dish to keep the compression the same. But Don, the thing is that you're not changing just quench. You're changing piston design. So if you saw a change, and if you were able to not change the static compression at all from that, you're changing piston design. And so you're changing airflow. So are you getting, if you do see a change, you may not see a change at all, but if you did see a change, what do you attribute that to? Are you attributing it to, because that's the thing with people get concerned about quench. I'm much more concerned with static compression ratio. That's a big thing. And then piston to head clearance, that's another big thing. And then quench is below those things, because you can't, it's hard to adjust quench without changing the other things. Just want to change from stock 89302 with a 97 Explorer 4-hole injectors. When you put any other injector in your motor, you're going to need to tune it, unless it's exactly the same size and exactly the same slope and everything is exactly the same. Otherwise, it's probably going to change. It might be in the range of adjustability of closed loop operation, but it's going to change. Have you tested restore? I have not. That's what Mark Sanchez was telling me. You need to put that in there and see if just try it and see if it does anything. Ladder flywheel won't make power at a steady RPM. It will show on the dyno though in an acceleration test. When we dynoed it, it picked up 5 pound-feet in the mid-range. Where did you dyno it? Where are these results at? Please show me. I'm always interested in more data. I saw the Slick 50 guys doing that. Rizlone? I've never tried that. Yeah, we're going down the rabbit hole again. I have a question you can't answer. There's lots and lots of those. Why are so many people worried about a cam, how it sounds rather than what it does? That's a big thing. I mean, people make the cams that have that cammy sound. That's why they came out with the mother thumpers and all those. Guys, I mean, look how popular idle clips are. I would make a lot more money on YouTube if all I did was post idle clips. People would love that. The idle clip channel. Ooh, I should do that, huh? Is timing chain loose on the trophy 4-cylinder? 85% saying yes and 15% saying no. We will end that right there. You need injectors with emulsion bleeds. Can you grab some motorcycle ITBs? Daniel, the Pontiac will have harmonic problems. That's been since its introduction. The next poll should be the idle clip channel. Yes. I'd like Jerry. I'd like to see it. If it is a direct back-to-back test, which is really hard for people to do, as you saw when we did our test, we were within the other side of the decimal point of no horsepower. So it's hard to get a motor to be that repeatable just running it back-to-back. So that's the level of repeatability I want to see if somebody shows me a test result. Because I've had people show me dyno results all the time. Look, it did this and did this. I'm like, look at those dyno results. This one was done 2 years ago. Yeah, but it's the same thing. I'm like, no, hard pass on that. That's not a back-to-back test. Honda K24 or J35. I like both of those. Build an intake with 3 1 barrels. That's what I was talking about doing on this one. What's it like working with Freiberger and Brule? They're good guys. I see Brule all the time. I don't see David very often, except when he's down here testing. But he's a really good guy. He's a hard worker. Have you ever tried to cool inlet charge on an NA engine using water to air intercooler using dry ice and antifreeze? No, I've seen guys do it. The example I always use, and this will be the last question because I got to get going, is I was going to do an extended version tonight of the live feed, but I wanted to start early, but then I started answering comments and that didn't happen. But at Bonneville, where you have high pressure air feeding the NA motor because you have so much vehicle speed, that the intercooling and NA motor works fairly well because you have pressurized air. So you can get it past what would otherwise might be a restriction for an inlet system that you're using to cool it. So if you can get past having a restriction, then colder air works on any motor. So many more good questions, but I can't answer them because I have to get going. So save your questions for tomorrow night. Thank you guys all for showing up. I've got to get back over to Mark's and do the 5-liter piston to valve clearance check and see what's going on there, so I can get that video up tomorrow. And